Thank you very much to everybody that came and joined us today. We've had, looks like 70 participants. We started with 50, 56, we ended up with 70. I haven't seen any questions pop up in the Q&A section. So we'll just give it 1 minute. However, if of course, if you have any questions, feel free to contact us at the virtual booth. It'll be manned for the next 2 days. So if I understand the link is by email. So if you have any questions at all, don't be shy. Don't hesitate, and then contact us, and we can set up a WebEx with you if necessary, or just a call. And as always, we're always available. So make sure you get in touch with us. Any questions about any of this or any other topics you need to bring up. I still don't see nothing popped up there in Q&A.
No. No Q&A. Closer.
Well, we're a minute or two early, but I guess at this time, I'd like to we could pass things over to Mark LeMay and Ramona Koch from Safran Helicopter Engines of Canada. They have a presentation to do as well, and we will pass it over to you guys. Thank you very much for everybody.
All right. Good afternoon, everyone. Thank you for attending the technical briefing today. Right, I'm going to have to try and start sharing my screen before we get going, if I get ahead of myself. All right. Okay. Okay, so here we go. Okay. All right. Yeah, I got the cue. Looks like I am on. Okay, so good afternoon, everyone. My name is Ramona Koch, and I am the Corporate Service Engineer for Canada. I provide technical support to all the Canadian operators via the field reps. So today's technical briefing was going to consist of the REL and the RS engines. Okay, I'll first start off with the REL 1 and 2. If you've got any questions along the way, please feel free to include them in your Q&A portion of the virtual room, and then I will address them at the end of the presentation. Okay, so the agenda for today will consist of the continuous reliability monitoring. This is where we're going to talk about engine mean time between failures, events related to the engine itself. And then we're going to cover some of the events that are related to mean time between unscheduled removals. So these are removals that are related to maintenance, and we're going to make recommendations accordingly. Midway through the presentation, I will cover technical issues that are related to the REL 1 and the REL 2. And then we'll end off the technical presentation with some continuous improvement objectives leading up to from 2019 up to 2022. Okay. All right, so reliability, continuous monitoring. Just 1 second. I'm going to stop my video because I got a message here that my audio is a little bit sketchy. So I'm going to reduce the bandwidth. Stop sharing. Okay. Hopefully, okay. So the video is off. So hopefully, the audio will flow through a little bit better. Okay. So where was I? So continuous monitoring. You're going to talk about technical issues that related to mean time between failures. So over the course of the years, Safran helicopter engines analyze data that come in from the MRO, from operators, incidents, and we take that data and we go through it with basically everything that we have and we come out with some analysis to identify the reasons for removals, the ones that are attributed to the engine, so mean time between failures, and mean time between unscheduled removals. Okay. So the mean time between failures for the REL engines, for the single engines, right now, that's 13,000 hours. So that's data from 2020. And for the twin engines itself, that's 16,000 hours. So it shows that the REL engines are very reliable, and the removals that are related to these type of failures are beyond the operator's control. Okay, so these removals can be mitigated through maintenance manual updates, like modifications of criteria, such as increasing like a periodicity of a borescope inspection, or they can be improved with modifications to the parts. So something to keep in mind is that not everything requires a design modification, but there are always corrective actions to reduce the type of removals. Okay, so now we're going to look at that chart that you see there. Okay, the top reason for removal for an MTBF is damage to the top meter bearing. So we have 5 cases in 2020. Second reason for removal, damage to the breather maxium. Third reason, damage to the second stage turbine assembly. And then for the last 2 reasons, coming in at 4 cases each. The fourth one being damage to the bearing at the bevel gear. And last one is damage to the gas generator rear bearing in the module 3. Alrighty, so this illustration, it shows you the location of each damage and the modifications that we've developed to reduce this type of removals. So as I said earlier, the top reason for removal is damage to the top meter bearing that's located in the module 5. Okay, previously with the old generation bearings, it was a triplex bearing. Since then, we've developed a modification to include a monoplex bearing that's more robust and resistant to skidding. So you just got 1 bearing instead of 3 bearings, working with the top meter piston. Second reason for removal is damage to the breather magnetic seal. We had 5 cases in 2020. So there is a dedicated study group to analyze the removals due to MAC seals. And this is not just MAC seals to the breather gear, but MAC seals that related to the starter generator, MAC seals to the power shaft, and the MAC seal to the for the fuel shaft that's located on the rear side of the module 5. So we've got a study group that's put together some recommendations, which I will give you more details later on in this presentation. Another thing that we've developed and improved on is a video installation tutorial that's available on Customer Portal. That video has been updated sometime earlier this year. So I do invite you to have a look at that video because it is very, very informative and does give you a very good illustration on how to install the MAC seal and little tricks that you should adopt. Okay. The third reason for removal, all right, is damage to the T2 blades. Okay. This has been an ongoing issue with the Area 1 engines. We had 5 cases in 2020, and we developed 3 modifications to improve this this issue that we see here. So the first modification is TU347. That is a completely new design to the blades as well as to the disc. And in addition to that, we improved the disc with TU365. And lastly, we identified more areas for improvement that were required, and that's TU384, which is an addition to the protective coating to the lower profile of the T2 blade. So that protective coating protects the blade against high temperature corrosion. Okay. Fourth reason for removal, we've had 4 cases of bevel gear damage that's located in the module 2 here. We're currently analyzing the reasons for those removals, trying to identify the root causes, and we are monitoring the events as they come in. And lastly, the 5th reason for removal is damage to the gas generator rear bearing. Okay. 4 cases in 2020, where we've got 3 modifications in place. The one is TU267, which introduces a more robust bearing. The other modification is actually TU360 that that involves the hollow shaft that's right here. If you follow my cursor, that's installed in the rotating assembly. So what we have noticed is that for those aircraft that are operating in a very fine particulate environment, like talking about talcum powder like, even if you do have a barrier filter installed, you've got to keep in mind that that's only 95% efficient. So with that 5%, there sometimes is a possibility of that very fine laterite accumulating into the hollow shaft and creating an imbalance in the rotating assembly. And as you can imagine, this one little bearing here supports the whole rotating assembly. So with a deposit in the hollow shaft, that could create an imbalance. And lastly, we also have conducted a quality audit on our side just to ensure that everything's followed, areas of improvements for assembly. Okay, so now that we've covered the area 1, I'm going to go into some insight into the area 2 analysis that we've done. Okay, for the area 2 single engine, okay, the MTBF is 17,000 hours. And for the twin engine variants, we have 1 unscheduled removal every 12,000 hours. So despite having these issues that we have with the engine itself is very reliable. Okay, so the top reasons for removals, the top 5 that we've identified. First one comes in as the free turbine rubs. We had 8 cases in 2020. And then 5 cases of the module 5 and the module 2 oil plug bonding. So oil leaking from these oil plugs. Okay. 5 cases for damage to the axial compressor rear bearing. 4th reason for removal, 5 cases of damage to the gas generator rear bearing in the module 3. And lastly, we have 4 cases of damage to the free turbine labyrinth. Once again, illustration of the location of this damage and the modifications that we've developed to mitigate them. Top reason for removal located in the module 4 is the free turbine. We've seen 8 cases of free turbine blade tip rubs. Okay. Something that we need to note here is that the clearances between the shroud or the blade path and the blade tip itself is very, very small. And that's because we need to extract as much energy as we can from the gases. But having clearances so tight, there tends to be some possibility of blade tip rub. So we have introduced a modification called TU215-215, which increases clearances between the blade tips and the shroud. Now it strategically increases the clearances at the 4 o'clock location as well as at the 6 o'clock location. So just by a little bit, but we're still able to maintain the engine performance. Second reason for removal is this is joint with the module 2 and the module 5 in terms of the number 2 spot. We'll start up with the module 2. Okay, so module 2, as you will probably be aware, is that there's a little oil duct right here, right? And that oil duct, it services the oil jet in the module 2. Okay, and the way this oil duct is drilled is that it's drilled from the outside in. So, and we plug that outside of the end bit of the duct with this thing, with a plug that's bonded together. So throughout the years, we've noticed that that bonding material that we use tends to wear off over time, so it starts to leak. So we've developed a modification to reduce this leak from the plug, and this modification is known as TU222. Okay, and that's an oil jet with a welded plug. So that plug itself now is welded to the jet, so therefore you have less chances of leaks. For those who are pre-mod, there's a service bulletin that's 292-72-2874, and that is an application of a silicon elastomer on the plug itself. So that will be a short to medium term solution. And then when your module 2 goes back to the repair center, we can apply TU222. Similarly, with the module 5, it's got a oil plug just at the front casing of the module 5. and that oil duct itself supplies oil to the jet, okay, oil jet in the module 5 to lubricate the bearings. So we've developed a new way to manufacture this oil duct, and that's known as TO221, and that modifies the drilling process of that duct. I've got more details later on in the presentation for this. And for those who are pre-mod, I would like to bring your attention to the service bulletin ending in 2873. Okay, that is application of a silicon elastomer as a short to medium term solution if you do have leaks on the module 5 coming from the area. Third reason for removal, axial compressor rear bearing damage. Okay, that's located in the module 2. We have a modification in place. It has a new design bearing that's more robust. So that replaces the front and the rear bearing in the module 2. Fourth reason for removal, kind of similar to the area 1, is the gas generator rear bearing. We are reviewing and monitoring the removals, but I do like to bring your attention to service letter 2746/09. This service letter is a reminder of oil coating solutions, because on most of the cases that we've seen where the rear bearing was damaged, there was a significant amount of oil coating in this area. So please, if your missions do involve a lot of, let's say, long idle times, multiple start stops in a short period of time, do have a look at this service letter 2746. Okay, so the fifth and the last reason for removals that are attributed to the engine itself is the free turbine labyrinth rot. We have 4 cases in 2020. Okay, that's located in the module 4, just behind the free turbine wheel itself, right here. So what we've seen with the original abradable coating is that it tends to behave in such a way that it forms amalgam during multiple, let's say, starts and stops, right? So if you're operating an EMS or certain missions that require you to shut down and restart again in a short period of time, that labyrinth tends to rub against the abradable coating, and that's the purpose of it, is to rub against it to create a nice seal. But sometimes with that coating, it comes off and forms an amalgam, and as a result, during your next start, you're going to have a free turbine seizure. So we've developed a new abradable coating, and that is known as TO213. So it's a more a coating that is, let's say, more forgivable and less chances of forming amalgam during the operation. Okay, so now I would like to talk about removals, unscheduled removals that could be improved or, let's say, avoided through maintenance recommendations. So MTBOR for the area 1 single engines, you have it at 5,500 hours. And for the twin engines, that's 4,700 hours. Okay, so that itself, you have one unscheduled removal, let's say on average, maybe about 5,000 hours. So these removals are due to maintenance that can be controlled by the operator. So as you can see from the top reasons for removals here, the top 2 reasons are erosion, corrosion, air path fouling, and FOD. So in total, just the top 2, we had 63 removals in 1 year, and that is in 2020. Okay. Third reason for removal, operator handling errors. So we had 11 events. Fourth reason for removal, 9 events of unconfirmed. So like the engines or the modules were removed, were sent back to us, and we could not identify the reason for removal, being an oil leak, for example, or starting issue or noise. So here, it is very important to actually contact your fuel rep prior to removing the engine. Last reason for removal is incorrect storage. Once again, we've updated our maintenance manual to be clearer in terms of specifications on the right way to store engines, but these removals can be avoided. All right, for the REO2, similarly as the REO1, the top two reasons for removals: erosion, corrosion, airpath fouling, and FOD. That's a whopping 69 events in 2020. Having said that, in your NTBUR for your Ariel 2 is 8,200 hours, so still a very reliable engine. Yeah, unscheduled removal for the Ariel 2 twin engines, okay, you're looking at 4,000 hours. And the third reason for the removals, unconfirmed, is pollution, performance, or pressure. So 14 events. And similarly, we've got storage conditions that were not correctly followed. We had 11 events for the Ariel 2. So the importance of this is to highlight that majority of the unscheduled removals can be reduced if you adapt your maintenance to your operating conditions. So in the event that you foresee that the aircraft is flying in a very salty environment or in a polluted environment, increase your engine and washing cleaning procedures, because that really helps a lot in recovering performances and reducing your repair costs. Okay, so as an example here, we did a very detailed analysis on the main contributing factors, which are erosion, particles, corrosion, that are introduced into the engine, right? And as a result, we've got performance degradation, premature removals. So this is our top unscheduled removal. So from our analysis, we've seen that if you take control of your corrosion, you wash your engines, the actual corrosion removal rate reduced by a factor of 4. So that's done by simply cleaning and washing your engines. And that then increases your T4.5 in your top margin. And that is all done by customizing your maintenance. It's proven. Okay. By doing that, you increase your engine availability, you reduce your operating cost. Okay. Because the airpath fouling causes a lack of airflow in the engine. And with airpath fouling, you have a loss of power of the engine. So that's huge impact on your engine aging. One thing I'd like to bring to your attention as well is that water quality is important. If you use plain water, like tap water, it has very, very high minerals. So when you dry your engine, you've got lots of deposits in your engine. So please use filtered water. Okay. So here I have a real life example to show that rinsing, washing, cleaning engine does work. Okay. In the top corner of your slide here, we have two photos. Okay. Here you can see that this engine is quite dirty. It's got a lot of probably salt deposits or some sort of particles in the combustion chamber, right? And before cleaning, the top margin at ISO T4.5 was 3.4%. After cleaning, that top margin increased to 11%. So that's an 8% increase by just cleaning your engines. Okay, that's very important and a significant increase. There is a service letter, a general service letter, GSL 3055, that was issued in October 2020. Okay, this service letter is very informative. It provides a description of environmental conditions that are typically associated to erosion, corrosion, and engine fouling. Okay. All right, so now it seems like the opportune time to just talk to you a little bit about safety management system. The previous slide that I had presented are kind of like in the spirit of Safran's mandate for our safety management system. So Safran helicopter engines, we focus a lot on adopting a safety culture, and we have put in place a safety management system. So the importance of it is that it encourages everyone, the OEM as well as the operator, to put in place a system that has a methodological approach towards managing safety, which includes the necessary organizational structure, includes your accountabilities, your policies, and your procedures, right? The SMS will only be effective through an understanding of the hazards in your organization, the associated risk, and the development of strategies to mitigate these risks. So it can be as straightforward as customizing your maintenance program when operating, say, in an erosive and corrosive environment. Or maybe, if you're already in an area where there's increased risk of fault. So by putting in safety nets, you're going to reduce your risk of faults. And as well as, say, the top two categories that I had mentioned before of unscheduled removals being erosion, corrosion, FOD, those two can be addressed, and therefore you'll be reducing those removals, right? So the purpose of risk management is to make sure that risks are managed to an acceptable level, and this is the way that it helps create an effective SMS. So as an indirect benefit, you would also lower your repair and unscheduled maintenance costs, which then reduces the risk of injuries. So as a result, the operations and maintenance are more consistent and effective. So in summary, hazard identification. So identify your hazard, you assess the risk, you analyze the causes, you put together the safety nets to prevent and mitigate the risk, and then you continuously monitor these plans. So this is the framework that Safran's been working on throughout our continuous monitoring. All right, so we're midway through the RL presentation. I'm going to talk to you about a few bits about technical issues on the REL. REL 1. Okay, so this I've heard from a few operators and as well as from my engineering department as being a top irritant is the magnetic seals on the REL 1 and 2. So, in putting things in context, all is observed during maintenance or during a pre or post flight check. So seepage of the oil onto the engine deck is no longer tolerated by operators, right? And customers have requested to drain the oil leaks, and some of the other OEMs have this method in place to drain the oil leaks into a common drain. But majority of our events are associated to starter max use. And as you can see here from the photos to the right of the slide, we've got a bit of oil that's coming through or pooling at the starter generator flange, and that's max seal that's in there. Okay. Root causes for oil leaks from the max seals, assembly process. The actual graphite ring in the max seal is very sensitive to shocks. So any minor chips or cracks or even dust could reduce the efficiency of sealing the oil. There's also this subject about the design and the repair process. There are limitations to the max seals, to the design of the max seals. Action plan that we put in place, we have one modification for the power shaft max seal, and on the REL 1 is called TU374, and on the REL 2 is known as TU182. We've also done several industrial improvements from the manufacturing and repair side of things. Throughout our analysis, we have identified that the roughness of the shaft in which the O-ring sits, right, does play a part in the sealing of that O-ring. So when we increase the surface roughness of those parts, we reduce the O-ring slippage on the shaft. So we've implemented a change in our manufacturing process by just increasing the roughness on the shaft by a few microns. That makes a difference. And another action plan that we've identified and put in place is the assembly method improvements. We've updated the maintenance manual and our repair manuals to ensure that the max seal is, the best practices are used to install the max seals. Right? And as I had mentioned a little bit earlier too, video tutorial is available on customer portal. Please go have a look at it. It is very instructive on how to install the max seals. One thing that we are working on, which is a modification, is draining the oil leaks from the starter generators to the starter to the common drain structure. You can see in the photo or this illustration on the bottom right corner of your screen is that's the starter generator mounting pad, and max is in there. We have let's say designed a drain pipe that goes from the flange all the way down to the common drain. This is still in progress. The study is still in progress, but that's the direction we're going to head to reduce the number of removals due to all leaks from the mag seals. Okay, so technical issues for the REL2. This is one of the top reasons for removals that I had mentioned earlier that's attributed to the engine. Okay, it's the module 5 oil seepage at the oil duct. Okay, this is noticed during a visual inspection. It's not an airworthiness issue, but what you may see is that you've got a bit of oil coming down on the front face of the module 5 from that oil duct and the nut and washer. And this happens because the bonding starts to degrade over time. So some corrective actions in place. Firstly, is that if you see it, it's more of an irritant. If your oil consumption is less than 200 milliliters per hour, then keep it in service until your next scheduled maintenance. There is a modification in place for it, right? And that modification that I had mentioned to you earlier as well, it changes the way we drill and produce the oil duct, right? With the pre-mod, okay, we would drill from the outside in, so outside of the modified casing into the duct for the oil jet, to access the oil jet, right? But now with the new modification, Q221, we drill from the inside out. So that's going in from the internal side that goes into the module 5. We drill it, we stop it before it reaches the outer part of the module 5 casing, then we stop. So this in itself this modification has been in effect since January 2021. So a fairly new modification, but we're very confident that it's going to stop this irritant. If you do have a pre-mod, I'd like to suggest that that you have a look at Service Bulletin 0873, right? And that is application of a silicon elastomer on the plug if you find it leaking while in service. Next topic I would like to share with you is the area 2D and 2E oil pump leakage. Okay, putting things in context, all was observed on the engine deck during a post-flight inspection, and the oil originates from the screws there on the oil pump. Root cause of it is that this particular screws, they don't seal the oil pump efficiently. All pumps concerned are all pumps with part number 0292 12 5130 and 5140. Typically, we've seen from our return of experience that the oil tends to leak with the oil pump less than 60 hours. Okay, so the screws that we've identified ending in 0230 have been installed on pumps with serial number below 4230 MTL. So these pumps that were manufactured before July 2020 have an issue with oil leaks. Okay, corrective actions that we've put in place. Firstly, we've developed new screws, the calibrated screws, part number 0292 120690. These screws have been installed onto all pumps with serial numbers ending in VEI, and on all pumps starting with serial numbers 4232 MTL. For those oil pumps that were already produced, we did a containment and we've applied Hylomar sealant on these pumps. So any pumps with serial numbers less than 4232 MTL have a Hylomar sealant on it. And on top of that, we went one step further for the long-term solution, is that we've developed a new oil pump with redesigned sealing screws. Okay, this is known as TU230, and we expect the service bulletin to be released anytime now before the end of this year. And this is just a different manufacturing process from the original cover where you would drill in and put a plug on it. So now we drill in into the oil pump on the cover from the internal side, and we put this self-sealing screws. So that If you do have an issue with the oil pumps for those Area 2 Delta and 2 Echo operators, please have a look for either the serial numbers that I mentioned here or with the application of TU230, which should be coming in the mailbox, in your email box soon. Okay. All right. So just in summary, through our all this continuous monitoring that I've been through in the following slides, in the previous slides, and through our just SMS and continuous reliability analysis, we've identified areas of improvements where we have diligently developed solutions, right? And this shows that in the last 3 years, we've developed a modification to improve the motor 2 bearing, right? That's TU212. We have increased cases of fuel coking, so we developed a modification to the fuel injection manifold, which is more tolerant to fuel coking. That's TU208. We've had some cases of power turbine blade tip rub, so modification to the shroud, TU215. Labyrinth seal coating, right, TU213. Module 5 intermediate gear bearing, TU230. So that's introducing more robust bearing to the front and rear of the intermediate gear. So it's more resistant to maximum loading. All right. And in module 3, we've got all sealing systems and improvement to the sealing. So improvement to the supply duct, the scavenge duct, and the vent duct. That's TU181 and TU202. Confirmation boxes, we've increased their reliability, improved it through TU192. Module 1 front support, TU197. And improvement to the front casing wear of the accessory gears, and that's TU194, which includes a bushing into one of the accessories, the actual 41 tooth gear. All right, guys and ladies, we're going to go into some information I'd like to share with you that concerns the SU, HMU, and accessories. Okay. So similarly to the bare engine, we also do reliability monitoring on the accessories, SUs, and HMUs. So for the Area 1 SU reliability, okay, the top reasons for failures. Okay. The first one comes in at 17 removals in 2020 due to match pistons out of limits. Yeah. Second reason for removal, 17 cases, damage to the NG and or the NTL seal. Third reason for removal, damage to the diaphragm of the deceleration control unit. And fourth reason for removal, static droop out of tolerance. Out of these 4 reasons for removal, we have developed 2 modifications that allows you to replace and repair these parts in the field. Okay. First one we shall address is the NG and the NTL seal. And you can look at the illustration to the right of the graph here. So the NG shaft variable seal, we developed an internal modification to it to improve the quality and sealing of the NG variable seal. And to address the seal, the fuel leak from the NTL seal, we've developed modification TU367. So this is an improvement to the dynamic sealing of the seal-off seal. So with these 2 modifications, you can replace the seal in the field as a level 2 maintenance. As for the deceleration control unit, we have implemented TU373, which is a modification that limits the diaphragm perforation. Okay. This DCU can also be replaced in the field. Okay. So moving on to the Arias 2, HMU reliability on the single channels. Top reason for removal, we had 5 cases in 2020, and that is damage to the drain valve assembly. right? So symptoms that you would expect here is you have a damaged drain valve, is start stagnation, slow start, fuel leak at the drain. This drain valve assembly can be replaced in the field. Second reason for removal, actuator resolver damage. There is a modification available, that's TU83, right? That increases the actuator reliability by improving the stepper motor characteristics. Third reason for removal, P3 body assembly anomaly. That's where in some cases we found a pierced P3 capsule, right? This P3 capsule can be replaced in the field as well as a level 2 maintenance action. Symptoms that you would see from a P3 capsule anomaly is slow start, aborted start, or even no ignition. Okay. Last reason for removal is rotating load limiter. So symptoms that you would see with this type of damage is a slow T4.5 increase during start. That's when the rack itself, the rack is distorted. Unfortunately with this, there's no fuel replacement available, so we'll just have to replace the complete HMU. Okay. REO2 dual channel HMU and TBF. Okay. Top reason for removal, we had let's say 82 cases of removals due to damage to the splines of the HP pump, LP pump, or the coupling sleeve. Okay. And this inspection is called out, as we all know, in the SB 29273-2851, right? This is for post TU 177 HMU, where it needs to be inspected every 800 hours. Second reason for removal is the LP pump assembly wear. So that's about 12 removals in 2020. Okay, drain valve damage, similar to the single channel. This is replaceable in the field. This one thing I'd like to bring to your attention is related to the HMU inspection. Alert SB 29273-2851, that's revision D, Delta, that was issued in May this year, May 2021. Okay. As a little quick refresher is that this SB requires you to inspect the HP and LP interpump splines every 800 hours, looking for signs of wear. What SB calls out, or the technical instructions call out as a demarcation of the splines. Okay, sorry. And here you see certain demarcation on the splines of the HP, the LP, as well as the coupling sleeve. But one thing that has changed in this SB, in the revision D, is the possibility of just replacing the coupling sleeve, right? But this can only be done if there's only contact wear on the HP pump, so the HP pump shaft. Okay, and that's just like little wear marks around here on the face of the HP pump shaft. If that's the only damage you see during your inspection in location 5, then you can keep the HMU in service by just replacing the complete sleeve. However, if you find some sort of demarcation or corrosion on the splines itself, whether it's on the pump splines or on the sleeve splines, then that still requires HMU replacement. Okay, so the medium term action plan that we put in place is TU210. So that's a DECU software modification. Okay. This DECU software modification, it monitors the low fuel pressure. It introduces this algorithm that's able to detect a low fuel pressure prior to an in-flight low fuel pressure indication. So this detection comes up as a test reference 185. This DECU software modification also introduces the signal in the event of a sudden interruption of fuel supply at the engine inlet. And in addition to that, it has a activation to the engine stop electrical valve to limit damage in case of a power turbine overspeed. So when your N2 goes beyond 120%. One thing that's very recent that's come up in customer portal is that in the event that you do have a test reference code 185, you are required to do perform an EDR dump. So our customer portal just last week has been updated to include a module where you can upload your EDR dump directly to customer portal. Right, and that is outlined in Service Letter 2072-21 RL2. So this makes everything more streamlined. So instead of sending it by email, through a Dropbox, because those files are very big, you can securely upload it to our server, and this data is then sent to the specialists who are then able to perform an analysis of your EDR dump. One reminder to our operators who have TU210 is that please remember to check your flight report maintenance page for test reference 185 or maintenance 001 at the end of each flight, because this reference doesn't pop out to you. You have to go through it to look through into the maintenance page of your flight report. Okay, so lastly, continuous improvement objectives. Just a brief overview of what we have done recently and what we plan to do in the future. So quickly, in 2019, we've removed the use limit life of the bearings on the RL1 and 2. The free roll has TBO increased to 5,000 hours. RL2 Echo has a TBO of 5,000 hours. In 2021, still before the end of this year, I think a few of you have been looking forward to that too, is that we are anticipating an increase of our injection wheel cycle limit on the RL2 pluses, the 2 deltas, the 2 echoes, from 8,000 cycles to 10,000 cycles. The package is with EASA. EASA is reviewing it, and we've been pretty much persisting with a response from EASA before the end of this year. We expect it to be a positive response, but of course, there's always the risk that EASA could come back and say no. But just watch this space, and I will be sure to advise our fuel reps once we get an answer from EASA. Okay, so in 2022, looking a little bit forward, a work in progress is that we are evaluating the RL2 Bravo 1, 2D, and 2 Echoes maintenance plan. And sometime in the future, forecast for the RL2 Echo is to extend your main inspection from 800 hours to 1,000 hours. All right, so that brings me to the end of the RL presentation. Do we have any questions? I'm just gonna go and look at my Zoom Q&A. All right, so far I don't see any questions. Okay, so I will, yes, kind of running up on the timeline here, but I'll continue with the areas. If you've got any questions later on, feel free to ask it at the end of the presentation or reach out to our fuel reps. Okay. Sorry, stand by. Nope. Bear with me, everyone. I'm going to share my screen now. Okay, so do you all see my screen? Okay, all right. Okay, so today, sorry, just got to get that organized. Sorry about that. I'm going to go back to the front. Okay, so Ari's presentation. Okay, so Aris 1 and 2, I'm gonna go through it in a similar fashion as the ARIA 1. We're going to talk about continuous reliability monitoring and TBF and TBR and the ARIS 1 and 2. And then we're going to elaborate into some technical issues for the ARIS 1 and the ARIS 2. Okay. Alrighty, okay, so the ARIS 1, okay, your mean time between failures is 4,100 hours. So that's about 1.3 times your engine overhaul life. The engine overhaul is at 3,000 hours. So you've got one unscheduled removal every 4,100 hours. Top 3 reasons for removals for the ARIS 1, because they only have 3. But the first one is a big one, is damage to the accessory gearbox bearing. We had 10 cases in 2020. And followed by 2 other reasons for removals. At 1 each is damage to the reduction gearbox output gear rear bearing, and 1 case of clogging to the rear bearing or return pipe. Okay, so quick illustration of the damage. Top reason for removal is module 1 accessory gear bearing damage, 10 cases, and this is associated to that bearing at the front and the top section of the module 1. TU-121 has been developed and it replaces the bearing with a riveted bearing that's more robust to certain forces that would have created a damage to the previous modification. Second reason for removal, just with 1 case, is damage to the output gear rear bearing. Okay, 2 modifications available for it. TU-114, which increases the rear bearing race strength, and TU-119, which improves the oil scan ridge flow path. So oil flows from the module 2 down to the module 1, and sometimes that affects the operation of the rear bearing in the module 1. Third reason for removal is clogging of the rear bearing or return pipe. Okay, there is a modification in place for that that's known as the non-return check valve, that's TU-285, which is installed in the scavenge line. Okay, and this stops any oil flowing back into the rear bearing area after engine shutdown. Now, if your engine is still persisting with coking in the scavenge pipe, please do reach out to your fuel reps, because there is a mechanical cleaning procedure that we can issue through a technical agreement specific to your needs. ARIA 2 mean time between failures in 2020, the MTBF for the ARIA 2 engines is 1 unscheduled removal every 7,900 hours. So that's almost let's say 1 removal every 2 overhauls. Okay. So your top reason for removal is 8 cases that's due to cracks in the combustion chamber. Right, and then we have the second reason for removal, 5 cases of the module 2 rear bearing supply and scavenge ducts that have cracks in it. The reason for removal, 4 cases due to damage of the free turbine NGV Omega seal. And 4th reason for removal is damage to the starter and breather mag seals. Okay. So first point, cracks in the combustion chamber. Right here in the module 2, okay, 3 modifications available for it. That's TU-117, which improves the fuel draining and optimizing the purging of the fuel system. Second modification available to you is TU-135, which improves the flame tube robustness, so introduces new material as well as the ceramic coating to the dome. And TU-142 is the thermal insulation seals at the injectors. I've got a slide later on to give you more details about these modifications. Second reason for removal, cracks in the rear bearing oil duct due to repetitive high tensile stress. So we have 5 cases in 2020. Okay, what happens here is that the end one end of the duct is connected to the outside of the turbine casing to the module 2, and the other end of the duct is connected right down here to the rear bearing support. So through each start and stop heating and cooling cycle, tensile strength is stretched. So the duct itself, we've seen cracks at the elbows. So we have introduced a modification TU-148, which essentially makes the old duct out of a stronger material that's more resistant to tensile stresses. Third reason for removal is damage to the omega seal in the free turbine NGB. This is a new occurrence for us. We have 4 cases in 2020 as a proactive as well as a monitoring action plan. We introduced a borescope inspection. We will introduce a borescope inspection for troubleshooting purposes in the case of back power margins specific to the negative T.4.5 margin. This is going to be introduced in your next revision to your maintenance manual in April 2022. And for the time being, we are still analyzing the events that have occurred. So 4 cases on the Arias 2B. 4th point, I think we all are aware of this, and I know that most, if not all of our Canadian operators have the latest and greatest magnetic seals. The 3 removals that occurred last year were on the pre-mod, so the old style magnetic seals, TU-87 and 89 on the module 1. That's introduced a magnetic seal that's called the lift seal, so that sealing and reliability is much better. Okay, so for the Arias 2, on the 2F itself, your mean time between failures is 8,200 hours. So it's a very, very reliable little engine that we have here, where you have only 1 unscheduled removal every 8,000 hours. The top reason for removal, 2 cases of high pressure sealing segment damage, and 2 cases of damage to the omega seal of the PT NGV. Okay, and that's where we see here. First point is sealing segment damage at the HP high pressure turbine section on module 2 right here. We have corrective actions in place in the repair center, but there's still an ongoing study to determine the root causes and reduce the segment displacement. Second reason for removal, it's also to do with similar to the Ariel 2B, is that you have a omega seal damage to this point. Okay, right, so MTBUR for the Arias 1 and the Arias 2. So the global MTBUR for the Arias 1 is 2,000 hours. So that's 1 unscheduled removal every 2,000 hours. And for the Arias 2, you have 1 unscheduled removal at 3,600 hours on the 2BXs, and on the 2F is 5,500 hours. But as you can see, and that's the same that goes with the Ariel engines, you see a top reason for removals is FOD, insufficient performance, or aircraft erosion. So it is exceptionally important, and I take this opportunity to highlight that we need to adapt your engine operation to your environment where the aircraft operates. On the Arias 2, we have options for an air intake filter to reduce erosion in your air path. But in the event that you are operated in a polluted environment, please remember to continue to clean and wash your engines, because the barrier filter does not stop chemicals from entering into your air path of the engines. Okay. Arias 1 technical issues. Yeah. Engine is damaged to the intermediate gear front bearing. So when you do have a chip light illumination and you pull the chip plug out on the module 1, and you find a little piece of metal that what could resemble like a tab, like a rectangular piece of metal that's about 2 millimeters in length, that is most likely the securing tab of the separating cage in your from the intermediate accessory gears. So right here. We've done a number of analysis through quality audits of manufacturing, assembly. There's no deviation to it. This bearing has been used in this engine for a very long time. There were no vibration issues, etc. So we could not determine the root cause for this, but nevertheless, we have upgraded the bearing to one that is riveted. So it removes the requirement of any securing tabs. It's a more robust bearing, and that is modification T121, and that has been in effect since January 2021. Can be installed in the maintenance center or the repair center. Okay. Second reason for removal for the Arius is damage to the output gear rear bearing. That's in the module 1 as well. You would see an engine chip light illumination. The cause for this damage is two things. One itself is the bearing that has high radial load in certain angles of the bearing. Second reason for its early deterioration is that the oil scavenges from the module 2 goes into the module 1 on the side of the casing, but any like very, very small debris that come from the module 2, like even cooked material, ends up polluting the rear bearing here. So the rear bearing prematurely starts to flake. So we have a TU114 that introduces a more robust bearing to address the max load of the bearings, and TU119 diverts or protects that bearing from the scavenge flow of oil that's coming from the module 2. Okay, Arius 2, technical issues. Okay, so combustion chamber cracks. Just like to share with you what we've done. These typically are found during your borescope inspections. And if you have a decreasing T4.5 margin, these are due to thermal stresses. And modifications that are available to you is for the ST135 on the 2B, TF82 in the 2S. And that's addition of a ceramic coating in the combustion chamber, right? TU142 on the 2B, TU85 on the 2F, that's thermal insulating seals. And lastly, we've got TU117. Okay, and this is what I'd like to highlight to you today and talk to you about is that HP sealing ring deterioration, and this is what we would see typically when you do have a low T4.5 margin in engine power checks, or you could just find it during a periodic borescope inspection where you have that turbine ring here that kind of makes its way out into the front of the HP. HP turbine. So as a corrective action, we're now systematically replacing the 4 segments during each repair process, as well as doing a dimensional check of the grooves where the segments sit. Okay, now this new case that's come to our attention in 2020 is the damage to the free turbine omega seal. Okay, symptoms that you see with this is unsatisfactory T4.5 margin during the engine power checks, and oil leak at the rear bearing area. That's only for very few cases where the actual all ducts of the rear bearing are damaged. But typically, this damage is discovered during a level 3 maintenance where there's contact wear of the omega seal. Okay. The omega seal is located right here between the rear bearing support and the free turbine NGV. Okay. And this just rotates in this area through micro vibrations, right? And somehow, to a certain point, if it does make it out of its housing, it may come in contact with the oil ducts. So that could cut the oil ducts and end up having some oil leaks through your module 2. Okay, the root cause is still being studied, but we put a monitoring action in place for a borescope inspection for troubleshooting purposes during your low power, if you have a low power check, specifically T4.5 margin. Okay, and this will be implemented into the maintenance manual in April 2022. Okay, and I've got just a couple more minutes here, so I'm going to briefly talk to you about this. It is what we've seen in the power turbine borescope inspection. All right, this was actually noticed during a borescope inspection where the power turbine blades come in contact with the PT NGV. There was a service letter issued in June 2020 and service letter 3050. This type of micro displacement is due to erosion and corrosion at this local pointy at the flange of the free turbine NGV. So with corrosion and erosion, sometimes the PT NGV tends to tilt toward the power turbine. And during the borescope inspection, you may see somewhere at the upper tip or some little marks at the aerofall section at the base of the turbine. Okay, so there is a 600-hour scheduled inspection on the front face of the power turbine. And if you do see this type of wear, there are allowances for it, but you can replace the power turbine in level 2. All right, and lastly, sorry, I'm going to miss this and talk to you about start injectors, which kind of ties in with the start electro valve. Okay, we've seen a number of cases with some of our ARIS operators of start injectors coking. Context put into place is that when your engine has start issues and you find that there's fuel coking in the start injectors. We've seen this fuel coking in the filter of the start injectors, item 30, as well as the duct itself. Okay. What we put together now is that there is a start injectors cleaning procedure incorporated into the maintenance manual. So you can use the cleaning procedure to clean your start injectors. There's still a dedicated working group to study the premature fuel coking issues. And it's also a contributing factor to start injectors coking is the start electro valve, which ties in with your start stagnation. Start electro valve itself, we've got 20 newly designed start electro valve that is being trialed with an EMS operator. The trial began about almost a year ago. So we are looking forward to the trials for this, the results from these trials, and hopefully it's promising. And if that's the case, then we will be able to put forward this modification to all the ARIS 2 engines. So modifications to the start electro valve, as well as the cleaning procedure to your start injectors. All right, everyone, that brings me to the end of the ARIS presentation. Sorry about the rushing through it, but just want to make sure that I've got all the information that I can share with you. Do we have any questions? All right, no, I don't see any questions at this time. Yes, not. Okay, so if afterthought, if there's any questions, feel free to reach out to our field reps or even to me directly, and I can answer them either through your virtual room, throughout HAC, or through an email. Thank you, everyone. And it's over to Mark.
Hi, everyone. Thanks for attending. I'll do it quickly. Thank you, Ramona, for the presentation. Thanks a lot, HAC, for hosting the event. And well, everyone, if you've got any questions, there's a lot of great features on the Engine Life portal, and you know how to reach us. So we'll be around all day on the virtual booth. And if there's anything, do not hesitate. Thanks a lot, and enjoy the rest of the day.